Hi everyone. Today we're going to keep talking about circles, and we're going to learn about something called a tangent line. So what a tangent line is, it's a line that's basically outside of a circle, and it comes and it touches it at exactly one point. So it can't cross through the middle of the circle because then it would touch the circle twice, once again on the way out. So basically a good way to think of it is a tangent line is on the outside of a circle, but it just barely brushes up against the circle, so it touches it at exactly one point. Kind of like this. So here we have circle P, and then you have that purple line, line QR, and you can see how the line is basically on the outside of the circle, but it just barely brushes up against the circle at point Q. So we would say that's a tangent line, and it's tangent at the point Q. Okay, so for our first theorem for today, when you do that, when you draw that picture, that tangent line, it's perpendicular to the radius at the point of tangency, or that point Q where it's tangent. Or here's a different picture. We have circle P again. This time the line is AB, and the point of tangency, the one place where those two things touch, the circle and the tangent line, is point A. So what you notice is it's perpendicular, it's a right angle. So if I draw the radius, which goes from point A to P, and then I draw the tangent line at point A, it's always going to make a right angle. And that'll give us our first example. So here we have a new picture. This time it's circle O, and I said line AB, which is that line going across the bottom, is tangent. And the point of tangency would be point T down there at the bottom. So I gave you some information. Let's label our picture here. So I said MS, this tiny little dotted piece outside of the circle here is 3. And I said the radius of the circle is 5, which is actually, when you say radius, you think, okay, it's right here. But it's also the rest of that dotted line. Now I want you to find the length of MT. So let's say I put an X down here between M and T. Now our theorem says that this is a right angle. The radius is OT, the tangent line is AB, and the point of tangency is point T. So what you actually have is a Pythagorean theorem question. If I redraw that triangle so it's a little bit less cluttered and it's not inside the circle, it looks like this. Here's the triangle and here's the right angle. This is a 5, this is an X, and for the third side here, if you notice, we have 3 here and 5 here. If I add that together, this is actually an 8 right here. So now we can do Pythagorean theorem. If you know 2 sides of a right triangle and you want to find the third one, you can do a squared plus b squared equals c squared. Now the one thing that's important for a Pythagorean theorem is the hypotenuse has to be c. So as soon as you find the right angle, which I marked in red there, if you go to the opposite side, this is the hypotenuse, the 8, and that's the one that needs to go here. Now the other sides, the x and the 5, are the legs, and they can be a and b in any order. So let's put the x here and the 5 here. So what I get is a squared plus b squared equals c squared, or basically x squared plus 5 squared equals 8 squared. And now we can solve for x. So let's do the squaring part first. 5 squared is 25. 8 squared is 64. To finish solving for x, the first thing I want to do is get rid of the 25. So I'm going to subtract 25 from both sides. The 25s are gone. It just leaves the x squared. 64 minus 25 would be 39. Now remember, we talked about this the first time through on the Pythagorean theorem. When you solve for x squared and you want to find x, you do that by taking the square root of both sides. So x ends up equaling the square root of 39. You can leave it as the square root of 39, that would be what we call the exact answer, or you could type it into a calculator. It would come out to about 6.3. Either of those answers is fine. So that's using our theorem. The theorem was telling us it's a right angle, which makes it a right triangle. The problem itself is saying, okay, it's a right triangle. That means I can use Pythagorean theorem. So we actually use two theorems in that one. Okay, back to tangent lines. Here's a new vocab word or vocab phrase. A circumscribed angle is basically this picture right here. If I draw two tangent lines that start at the same point, so that's point B. You know, you take point B, you have circle X, you take point B there. If I draw two different tangent lines, one kind of goes up and meets at point A, the other one moves down and meets at point C. That's what we call a circumscribed angle. It's an angle where the circle is kind of like squeezed right in between it. Okay, now that we know what a circumscribed angle is, here's a theorem about those. So here's our second theorem for today. Our theorem says that if you draw that same picture, in fact, I'll use the same picture. It says if you draw a circumscribed angle, then the two line segments that you make, meaning from point B, where the two things started, to their points of tangency, are going to be congruent. Or basically, AB, which is this line segment right here, is congruent to BC, which is this one down here. So if you draw two tangent lines starting at the same point, we're basically saying the distance from that point that you picked up to each tangent line is going to be the same. Or up to each point of tangency, I should say. So let's turn that into an example. This will be it for us today. In this picture here, let's find the length of AB. So I look at the question, I say, okay, before I worry about finding AB, this is a solve for x question. I can see there's x. I have a 3x plus 2, I have a 7x minus 30. Whenever there's a solve for x question, you want to find the relationship between the two expressions in the picture. Well, what we just decided, in fact, I used the exact same picture. What we just decided, since I'm seeing a circumscribed angle, this line segment is congruent to this line segment. And that means this measure, 3x plus 2, is equal to this one right here, 7x minus 30. And that's the equation we're going to solve. We're going to solve 3x plus 2 equals 7x minus 30. And I look at my equation, I say, well, I have x's on both sides. Let's get rid of the smaller one. Let's do a minus 3x on both sides. So that one's gone. It leaves just the positive 2. And on the other side, 7x minus 3x is 4x. And we still have a minus 30. Okay, if I'm solving for x, the next thing I want to get rid of is the minus 30. And to do that, I will use a plus 30. And of course, as always, same thing on both sides. Minus 30 and plus 30 are gone. 2 plus 30 is 32. And over here on the right, the only thing we have left is the 4x. So one last step, if I have a 4x and I want to cancel the 4, I divide. So I'm going to divide both sides by 4. This 4 cancels with this 4 and just leaves the x. 34 divided by 4 is 8. So I've solved for x. And remember, whenever you solve for x in one of these questions, before you move on to the next question, go back and look at the directions. So what I actually asked you to do was find AB. Meaning we needed to solve for x, but that's not the answer to the question. So don't box it up and move on. AB is this line segment right here, from A to B, which means it's 3x plus 2. So what we want to do is we want to take that 8 and we want to substitute it for x right there to get our final answer. So for the final answer here, I'll squeeze it up here on top. I'm going to take the 3x plus 2, because that's AB, and I'm going to substitute the 8 that we just found for x. So I have 3 times 8 plus 2. 3 times 8 is 24. And 24 plus 2 is 26. So the answer isn't 8. We needed to do that. We needed to figure out that x is 8. But the actual answer to the question is 26. And one thing I've told you in the past, a good way to check your work is try plugging 8 into the other one. Because remember, these things are supposed to be equal. 3x plus 2 and 7x minus 30 should be equal. So you can check your work, make sure you were right. You can say, okay, well, what's 7 times 8 minus 30? You say, well, 7 times 8 is 56, and 56 minus 30 is 26. So now we're like 100% sure we definitely did it right. We had the right x. We're getting 26 for both of them. The answer is definitely 26.